Welcome to my video on 10-3, the equation of a circle. Today we're going to write and identify the parts of the equation of a circle and, go back and forth between identifying it from the circle itself and from the equation. So the first thing, just to refresh our memory from our geometry skills, is I have a circle here on a coordinate plane, and I'd like for you to identify the center and the radius of the circle. Okay, so most of us are fairly comfortable identifying these parts, right? They're even labeled here up on my circle. The center is going to be -3, 3. We get that from looking at this dot right here and moving over 3 spaces and up 3 spaces. My radius, which is the distance from the center of my circle to the edge of the circle, is going to be this right here. Right, so if we count the boxes 1, 2, 3, 4, 5, and 6, we see that our radius r is equal to 6. Okay, so now we're going to take these two parts of the circle and use them to write the equation of this circle, so that if we were to graph it, we could. So the standard form of the equation of a circle is this right here: x minus h squared plus y minus k squared is equal to r squared. H comma k being the center of the circle and r being the radius. Now, remember, this equation is going to be mixed up with all the other questions from this conics chapter. So how do we know this is a circle? Well, the fact that both my x and my y are being squared is the key indicator here that we have the equation of a circle, okay, as opposed to our parabolas, which only have one or the other being squared. Okay, so if we were to take a look at an example of this equation below, we have x minus 2 squared plus y minus 1 squared is equal to 25. So if we rewrite that as that 25 as a 5 squared as opposed to 25, we should be able to identify the parts right from the equation itself, right? The center, without graphing it, is going to be, right, this x value and this y value, opposite sign of what you see in the equation. So that is 2, 1. And my radius is the value that's being squared. So in this case, it's going to be 5. Now, if that number was not a nice perfect square like 25, we would have a radical as our radius for calculating. But we don't in this particular example. So if we were to graph this, right, this is what it would look like. We have the center at 2, 1. We count out the radius, and we would have to, swing that radius all the way around until we had our perfect circle. So we're going to experiment with our equation, writing equations and different things of that nature based off different types of information given. So in this question, we're being asked to write the equation of a circle with the center 1, -3 and radius of 10. So as soon as we see equation of the circle, we should write down the formula that we know. X minus h squared plus y minus k squared is equal to r squared. Okay, and then we plug in the values that we see. So we know, since this is the center, that's going to be h comma k. So we can plug in x minus 1 and then y minus a -3, which actually works out to plus 3. And then we have our r squared, which is 10 squared, which we know to be 100. Okay, so if we were to write an equation, those are the parts that we would need to fill out. Okay, so that's working towards writing the equation. We could also be given an equation and asked to find the center and the radius of that particular equation, different from the do now, which was finding the center and radius from the picture. So looking at this, again, we are comparing it to this particular standard form. So if we just compare it to this example, we can pick out that this 2 is going to be related to the h, and that this 10 is going to be related to the k. Now, because this is a positive 2, that means my center is going to be a -2 in my x position. And because that's a -10, we will get a positive 10 in my y position. And for the radius, we have to look at our value at the end and think about what is the square root of that value. So in this particular case, it's 2, so my r value is going to be equal to 2. Okay, so now, just slightly different. In this below example, we have just an x squared, different from the x in a parenthesis with a value. So what does that mean? Well, if we're taking a look at this example, right, thinking back to our parabolas, right, what did we do when we just had an x being squared with no other terms? Well, we assumed, right, that was like we had a minus 0 in that position, right? Because we know that minus 0 doesn't change the value, so we could just simplify it to a plain x squared. So if I rewrite everything else, now we are in the form in which we can identify our center and our radius, one of the values being 0. So here for our center, we have 0, negative 3. And for our radius, we have the square root of 25, which is 5. Okay, so anytime we have an x value by an x squared by itself or a y squared by itself, with no other terms, no parentheses, we can assume there is a minus 0, which represents the 0 being in that place of the center. So now that we know how to work with these equations, right, we should be able to sketch them, right, and translate them. Translate them meaning move them across the coordinate plane. So x squared plus y squared equals to 25. As I said before, right, anytime we just have an x squared by itself and a y squared by itself, we can assume that there is a minus 0 at the end of that, right? So that means my center here is going to be at my origin, 0, 0. Okay. Now, in order to be able to sketch this, which means that it's an imperfect graph, right? We're just giving the general shape. We also need our radius, which is going to be square root of 25, which is 5. So if I wanted to draw a quick sketch of this, I could count out all the boxes that I know are exactly 5 units away. So 1, 2, 3, 4, 5 going to the right, 1, 2, 3, 4, 5 going up, 1, 2, 3, 4, 5 going left, 1, 2, 3, 4, and 5 going down. And knowing that these are going to form a circle, I can make a nice little rounded edge. So there's a sketch of my original circle. Now, I'm being asked to translate this 2 units to the right and 4 units down. So when doing this, because we need the center for my equation, it is best to focus on the center when we are translating, right? So we're going to take this point and we're going to move it 2 units right, and we're going to move it 4 units down, making the new center of my circle the point 2, negative 4. Now, when we are translating, our radius does not change, so it should stay a 5. So based off of that information, we can go directly into our equation by plugging in a 2 and plugging in the negative 4. And then plugging in the 5, which would give me 25, making my new equation x minus 2 squared plus y plus 4 squared equal to 25. Now, you might notice, right, this switch is the result of subtracting the value that we have shifted. So, because I'm moving right 2 units, meaning in a positive direction, I'm going to subtract a positive 2. And because I'm going down to 4 units, which is a negative direction, I'm going to subtract a negative 4, and that is another way in which we can do our translations without actually graphing the picture on the page. Okay. So now we're going to step it up a notch and talk about what the center and the radius is of the following circle. But this time we're not given those factor bubbles, right? We want it to look like this in the end. X minus h squared plus y minus k squared is equal to not 25, r squared. But we have to kind of manufacture that. We have to create that. So in order to do this, right, we see that we have an x parentheses and a y parentheses. So the first thing we're going to do is we're going to separate our x's from our y's. All right, we'll write the x's together, we'll write the y's together, and we'll leave some spaces here. And the reason I'm leaving spaces here is because in order to get these two terms to look like this factor bubble, we're going to have to complete the square, right? Meaning find the value that makes those three terms a perfect square trinomial. So if we're looking at x squared plus 12x plus a blank, remember we're taking b over 2 squared. And the b is always going to be, right, the non-squared term coefficient. So for the first two terms, we have 12 over 2 squared, which is 6 squared, which is 36. So I'm going to add 36. But remember, what I do to one side, I must do to the other. So I must add a 36 to this side of the equation as well. Now we're going to do the same thing for the y values. We're going to take 14 divided by 2 and square it, which gives me 7 squared, which means I'm going to be adding a 49. But again, what I do to one side, I have to do to the other. So that's the only way that we're going to have a balanced equation, is if I add those two values on the left, I must also add them on the right. So now when we rewrite our equation, we should be focusing on those three terms together and these three terms together. So focusing on the x terms, we see that this actually factors to x plus 6 squared because it's a perfect square trinomial. And we are going to add to that what the second three terms factor out to, which is y plus 7 squared. And then we're going to add everything on the right-hand side, which actually works out to a 1. So now we are in the format in which we can pick out our center and our radius. Our center is going to be the opposite signs of these values, so we'll have a -6 and a -7. And our radius is going to be the square root of that value, which in this case, square root of 1 is 1. Okay, so when we see these jumbled up terms and we see multiple values with the same variable, we're going to have to use complete the square to create the equation of the circle. Now, the last thing that we could be asked to do is to find the equation of the circle given 2 points, one of which is the center. So there's a couple of ways in which we can do this. But basically, we know for this equation that we need two things. We need our center, which we have, and we need our radius, which we don't. So first I'm going to plug in my center because it makes the equation a little bit simpler, right? So it's x minus 0 squared plus y minus 0 squared is equal to r squared. Now we know from earlier that anything with zeros we can drop. So we get x squared plus y squared is equal to r squared. Okay, so now the question is, how do we find the radius based off of this second point? Well, if I were to graph it, 1, 2, 3, 4, 1, 2, 3. Basically, we are trying to find the distance between this 0, 0 and this 4, -3. Now, there are 3 ways to do this. The first of which is to actually use the equation itself that we have plugged in. Because we have an x, we have a y, all we need to do is solve for r. So method 1 is to use the equation. So my x value is 4, my y value is -3, and we are solving for r squared. So that's 16 plus 9 is equal to r squared. That's 25 is equal to r squared. Take the square root of both sides. We get 5 because we don't have negative distance is equal to r. Making my new equation, right, x squared plus y squared is equal to 5 squared, which is 25. Okay? But that's not the only way to do this, right? As I said before, we are trying to find our distance between those 2 points, right? So another option here is actually to use the distance formula, which you learned in geometry. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. x1, y1 being one of our points, in this case the center, and x2, y2 being another one of our points, which in this case is the 4, -3. So if I plug into that equation, we have 4 minus 0 squared plus -3 minus 0 squared, which if we keep looking, ends up being the same 4 squared plus -3 squared, which is 16 plus 9, which is the square root of 25, making that distance, right, from there to there, equal to 5, okay? So that is method number 2. And the last and final method, which is going to be an important method when we go to trig, is to use a triangle to be able to calculate the measures. So what do I mean by that? Well, looking at this picture, we see that we have a diagonal line. If we were to draw basically a vertical line directly to our x-axis and connect it, we form a right triangle. So knowing that this side of my right triangle is 4 boxes and this side of my right triangle is 3 boxes, I can use the Pythagorean theorem, right, to calculate the length of the hypotenuse of that triangle, right? So we can use a squared plus b squared is equal to c squared to calculate. Now you may recognize that this is a 3, 4, 5 Pythagorean triple and recognize right away that it's equal to 5. But if it wasn't, we would just have to substitute 4 for the one side of the triangle, 3 for the other side of the triangle, and then solve accordingly, which works out to be mostly the same calculations as above, giving me 5 as my radius. Okay, so any of these methods are valid and would get you full credit. I do encourage you to explore method 3 because we will be using that with our circles. And that's all we have for today. So here's the homework. I ask you to give these a try, give it your best effort, and good luck.